Here's the Law of Definite Composition lab, so make sure you have this out either digitally or hard copy in front of you. To do the pre-lab, I'll actually do these as I go through the procedure, so I'll give you a warning when these are coming, so just skip them for now. And then the procedure, what you're going to need to do is start a Bunsen burner. Now you should adjust the Bunsen burner so you see an outer like flame and then an inner blue cone, a darker blue cone. It's not the easiest to see here, so I hold up a book that kind of makes it a little easier. You can see like the inner darker blue cone. The tip of that inner blue cone is the hottest part of the flame. So that's the level that you want the crucible at. Okay, so pre-lab question number 1. Why do you heat the crucible at the start of the experiment? So you heat it. The reason you heat it is because it could have like oils from my fingers right there. It also could have a little bit of water vapor on it. So the reason we heat it up at the start of the experiment is to dry it off, to make sure it's clean and dry. If there's anything on there that could be evaporated away from the flame, we want to evaporate it before we weigh it. So it takes a few minutes, then you gotta let it cool before you weigh it. Okay, so now that we've dried the crucible, let it cool, we'll take the mass of it empty. And we always take the mass with the cover on. And you can see that I put textbooks around the balance because there's a draft in the room. And they help keep the air around it calm. So you'll see how steady the balance is when we do that. And the measurements are very fine, so we want to make sure that we have a good reading. There's not going to be much of a change in mass, so we got to be very precise. So you can see it's definitely 33.37 is what I would record. And then the next pre-lab question is coming up. Why do we make sure the outside of the magnesium strip is clean and shiny? It's hard to see here, but there's a little bit of corrosion and kind of just gunk on the outside of it that just needs to be scraped off. So when we weigh the magnesium, we want to make sure it's pure magnesium, not magnesium with all the other stuff that's on it. We want to make sure it's pure. The other thing in the procedure says to coil it up so that it sits flat on the bottom of the crucible. So we've got shined up at this point and coiled up. Now we're going to take the mass of the crucible, the cover, and the magnesium. And we always measure it with the cover on. So we've got our cover there, you see it's still 33.37. We're going to add the magnesium and remass it. Now the difference between that last reading and this one is going to be the mass of the magnesium. So you take this one minus that 33.37 to get the mass of just the magnesium. So this is the second data point. Now at this point we got to heat it to get it to react. So what element does magnesium combine with? It combines with oxygen, or O2 is the formula for it. So as it reacts, it's going to be pulling in oxygen. So we heat it, we got to get it very hot when we heat it this time. Make sure we get the magnesium to react. Again, we want the bottom of the crucible to be at about the level of that tip of that inner blue cone, that darker blue cone of the flame. That's the hottest part of the flame. The other thing is when we do this, we want to make sure that the cover is offset a little bit to vent, to let some oxygen in, because it is reacting with oxygen, remember. And you see it does get very, very hot. And there's an observation that says, how do you know that it's reacting? So the next video, the next clip will show you inside while it's reacting. You can see in there it's glowing. It actually gives off a very bright white light while it reacts. So make sure you record your observations. And then once the reaction is done, if you look in there, it's a little bit of a glare, but you can see it went from a silver metal to a white powder. There's a better shot of it coming here. So you can see that coiled up strip, what it looks like now. And you can see there is a little bit of like white powder on the cover. That's why we always weigh the cover with it, to make sure we capture any of that mass that may have gone up on the cover. So now we'll take the mass after the first heating. And again, this is why we include the cover every time we weigh it, because there may have been a little bit of that's splattered up there and stuck to the cover. So it looks like you put either 33.59 or 33.59 would have worked. And then we heat it a second time. The reason we heat it the second time is to make sure that all of the magnesium reacts. So what we're checking for is, does the mass go up after we heat it the second time? So we'll see. If it's still going up, we probably want to reheat it a third time, because that means it's still reacting. But in this case, we look, it goes 33.59, 33.60. So that tells me that it was done reacting the first time, but it's always good to reheat it to check. So pre-lab question 4, why do we reheat it until the masses differ by no more than 0.03? It's to make sure that all the magnesium is reacted. So we can't actually look at the atomic level and see if every magnesium has reacted with an oxygen atom. So our best way to do it is an indirect test of heat it, reheat it, heat it, keep reheating it, heat it, weigh it, heat it, weigh it. If the mass isn't going up anymore, we can assume that all of the magnesium has reacted. Now that we've got all our data, there's some calculations. So I'll give you some hints here. You can skip this if you think you got it. Otherwise, watch this, come back and watch it if you need to. I labeled each data point A, B, C, and D to just kind of make this easier. So to get the mass of the magnesium, you got to take the mass of the crucible, cover, and magnesium, subtract it from the crucible and cover. So you take your data point B minus A. So you take your number on line B minus your number on line A. Then to get the mass of the final product, you take the part D minus part A. And make sure you show your work. Make sure you show me what you actually subtracted, the numbers that you subtracted. Now to get the ratio, you're going to take your answer from question 2, divide it by your answer from question 1. It almost feels like filling out your tax forms. Take line A minus line B. Oh, you get to enjoy that someday. And then for the last part, the relative error equation. Don't forget its absolute value. I think I forgot that on there, it looks like. The A value is given to you, as always. And then your O value will be your answer, the number that you get from part 3, or calculation number 3. So get those calculations done, show your work. And then the questions, do as many of those as you can. I will go over 1 or 2 of those in class.